Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. The Remer-Tiemann reaction involves treatment of an aromatic compound with CHCl3COH, which generates dichlorocarbon CCl2. When applied to cyclopentadiene-containing systems, the carbene inserts into the diene to expand the ring. Moving on to the next step. Identify the starting material. The structure shown is indene, a bicyclic compound consisting of a benzene ring fused to a cyclopentene ring, 5-membered ring with one double bond. Moving on to the next step. First reaction, indene plus CHCl3COH, A. The dichlorocarbon CCl2 generated reacts with the double bond in the 5-membered ring of indene. The carbene adds across the double bond of the cyclopentadiene portion. Via ring expansion, the duoring-Laflamme or related carbene ring expansion, the cyclopentene ring with the added CCl2 expands. The dichlorocarbon adds to the double bond in the 5-membered ring, followed by ring opening expansion to give a 6-membered ring with gemdichloride or a chlorinated product. More specifically, carbene addition to indenes C is equal to C in the 5-membered ring gives a bicyclo intermediate which ring expands to give 1,2-dichloronaphthalene or a chloronaphthalene derivative. Actually, the known reaction indene plus CCl2 via cyclopropane intermediate and ring expansion to chloronaphthalene or dichloronaphthalene precursor. And for the final step, the reaction of indene with CHCl3COH, dichlorocarbon, proceeds through cyclopropane ring formation on the double bond of the 5-membered ring, giving a norcaridine type intermediate, bicyclo, 3.1.0, system with CCl2. This undergoes electrocyclic ring opening to expand to a 6-membered ring, giving a naphthalene precursor with 2 chlorines. The product, A, is 1,2-dichloronaphthalene, with the 2 chlorines on adjacent carbons of one ring. Second reaction, A, plus CHCl3COH, B. Now, A, already has a naphthalene framework. Treatment again with CHCl3COH under Remer-Tiemann conditions on the naphthalene with existing chlorines. But more likely, if A is a partially unsaturated intermediate, not yet fully aromatic, the second carbene addition occurs again. If A retains a double bond available for carbene addition, a second ring expansion or substitution occurs. The starting indene has the 5-membered ring. First CHCl3COH adds CCl2 across the double bond in the 5-membered ring expansion to give a 6-membered ring product. A has a fused bicyclic system, naphthalene-like, with Cl substituents at specific positions. Second CHCl3COH treatment gives product B, indene reacting twice with CHCl3COH, dichlorocarbon, gives a product where both additions have occurred with ring expansion. The final product B is 2,3-dichloronaphthalene, option A, where the 2 chlorines are on adjacent carbons, positions 2 and 3, of the naphthalene ring. This corresponds to the 2 chlorines appearing on the same ring of the naphthalene system on adjacent carbons, as shown in option A. Why other options fail? Option B1, 6 substitution would require non-adjacent additions inconsistent with the sequential carbene additions to the same ring system. Option C2, 6 substitution similarly does not follow from the regioselectivity of sequential carbene ring expansions on indene. Option D1, 8 peri positions would require a different mechanism not consistent with carbene addition ring expansion sequence. Therefore, the correct answer is A. Therefore, the correct answer is option A.